Hello world and welcome to this edition of Tech on Fire with Blaze. I'm Blaze Stewart, architect at Atmosera. Today we're going to be taking a look at a recent project I did where I did a PC build for work. Hi guys, today I wanted to talk about a recent project that I did that's not related to Azure. I recently built a PC for work, and this PC is one that I custom built for the kind of work that I do, which is mostly software development. Of course, I do a lot of work on Azure, but a big part of that is writing code that will eventually run on Azure. In addition to that, I do other things like video editing and things like that as well. So I wanted to build a PC that was optimized for these kinds of workloads. So I'm going to talk about why I selected the components I did, and then I'll walk through how I built the PC, which is really not that complicated, but I'll just show you a tour of what I did and some of the caveats that I ran into when I was actually building this computer. So these are my PC building goals. My primary PC building goals are for software development, and to do that you need a lot of different kinds of things. You need IDEs, debuggers, compilers, databases, browser servers, and other kinds of tools that go along with this. So the IDE is the primary tool that you'll use for writing code, but it's bundled with a lot of things that run in their own processes like debuggers, compilers, and databases to support that kind of work. And then you'll have browsers if you're doing web-based apps, and then of course the servers that go along with that. So you might need web servers and other kinds of servers that support the kinds of activities that web apps typically use, then a myriad of other tools that come along with that. So all of these things require a lot of tasks running in memory at the same time. So you really need a CPU with a lot of threads to be able to handle this well. And sometimes you end up running the same suite of tools right here inside of a virtual machine. So a virtual machine might be running a different operating system, and then it has different tools in that operating system that are doing basically the same kind of tasks that you might be doing in the host OS. So you might end up doubling the capacity of what you're doing in the virtual machine and the host OS simply by having two operating systems. So ultimately, all of that requires a lot of memory to be available to the system so that it can be able to process all these tasks and all of these virtual machines at the same time. Now in my world, I typically do a lot of video editing while I'm doing these kinds of tasks, or I might be doing live streams at the same time. So I need to be able to do video editing, which comes with its own set of tools, and it has its own demands on the CPU and the GPU and things like that. So that's my primary set of requirements. My secondary requirements are these right here. Now I need to do some ML and AI occasionally. Now that's not what I do on a day-to-day basis, but that typically requires some kind of GPU to do that. Graphics editing and photography become a part of video editing many times. So you end up building graphics that you need to put into your video presentations, or you might be doing photography work, which I do with a DSLR sometimes, that it goes along with video editing at the same time. And occasionally I do game. I'm not an avid gamer anymore. I used to be a fairly avid gamer where I'd play a lot of the more modern titles. I don't really do that as much anymore. I've kind of switched hobbies to writing, which I have a whole nother PC for, but I do like to game on occasion. So a machine that will play the games I play is probably going to be fine. So I don't need the top of the line components to play the games at the kind of resolutions and with the glitz and glamour that I like. But and all in all, these are the kinds of goals I have for building this PC. Now to make this all happen, I basically need a machine that has breadth of compute. And by that, I mean lots of CPU threads and lots of RAM. And I'll dig into that in just a second, what I mean by breadth of compute in another slide. And then I also need fast storage for coding and videos. Now, fast storage is crucial for building code because a compiler or a database is going to be reading and writing from storage in quick succession. So it's random reads, it's random writes from all over the drive. So you need a disk that's going to be able to handle that kind of read and write operations. It's not so much about just linear throughput as much as it is about the ability to do a bunch of IOPS on the disk. So you want to get a disk that supports that kind of workload. Now for my secondary goals, I really just need a decent GPU, but I don't really need the best because AI and ML typically rely on a GPU, but at the level that I do it, I don't need a top of the line GPU to handle that. And graphics editing and photography and gaming all kind of use GPUs nowadays, so I don't need a top of the line GPU for that kind of work, but a decent GPU nevertheless will make that work a lot better. So these are my goals. Let's go and talk about the components that I selected and as well as what I mean by breadth of compute. To help you understand what I mean by breadth of compute, there's really two kind of metrics that I looked at when I was selecting a CPU. And the first one is the number of threads available on a CPU. And that's basically the number of threads that I need to have available to me for running all those tasks. And the other one is clock speed. So clock speed used to be the only metric that we considered, but now we have kind of a two-dimensional view. Now I know that this is a kind of simplistic view of this. There's a lot of things that go into performance, such as the speed of your RAM, how efficient your cores are, how well you cool your CPU, and there's a lot of other things, but these two things kind of help create an area that helps me compare CPUs to other CPUs, even if they're in a separate generation. So looking at these two different metrics, you can kind of see an area of the breadth of compute available to a CPU. And my first CPU that I had about 3 years ago when I did my first build when I came to work for Wintellect was a 6th gen i7 HQ, which is a mobile variant of the i7, and it had 8 threads at 3.5 gigahertz, which was a decent CPU for the time. The next one I had was in a build I did about 3 years ago, and I did a video on that. I had a 9th gen i7. It had 12 threads at 4.6 gigahertz. So this had a pretty significant boost in the clock speed, as well as a modest boost in the number of threads that were available to the CPU. So this one served me well up to a point when I started running into ceilings with this particular CPU. I would have this CPU maxed out at many times when I'd be doing video editing as well as trying to do dev work and VMs and all the kinds of things that I do on a regular basis. So to kind of compensate for that, I really wanted to drastically improve the breadth of compute that I have available to me in my next build. And that's why I ended up going with a desktop over a laptop, because I could do that with the CPU I selected, which is the 12th gen i9 KF. And it doubled the number of threads available to me, and it runs at 5.2 gigahertz. Now, it has 16 cores in it, but it has what they call efficiency cores and performance cores. And the performance cores are basically dual thread cores or hyper threaded cores, and the efficiency cores are single threaded cores. And so 16 cores combined, so you have 8 with dual threads, so that gives you a total of 16 threads plus 8 more. That will give you a total of 24 threads available to this particular processor. And it did give me a slight boost in the clock speed, so this over doubled my compute capacity if we look at it just strictly from threads and clock speed. So this particular machine has quite a bit of room to expand my compute capacity for the kind of tasks that I'm going to be doing on this machine. So now that we've talked about the rationale for what I did, let's look at the actual component list and look at the what I actually chose to put into this PC. Now I'm going to look at it like this. I'm going to look at the component and the cost. Now my budget for this was about $2,500. The total on this is about $2,300 if you add it all up. Add some tax and some shipping to that, it came out to just over $2,500. So the first components that I selected were the non-negotiables. These are the ones that I must have to make the priorities work for the goals that I have in mind for this PC. So I went with the 12900 KF in this case. The 12900 KF is the non-GPU variant of this particular i9. It doesn't have the integrated GPU. I went with that one mostly because it generates less heat because it doesn't have the integrated GPU, and it forces everything over to the inserted GPU, which is an NVIDIA GPU in this case. And this particular one was a little bit cheaper, so I went with this one. Now the difference between the performance on this one and the K and the KS version really depends on the Silicon Lottery if you want to get that. But in any case, I've already talked about why I selected this with breadth of compute. Now for storage, I went with this Samsung 980 Pro. These are some great drives for performance. They do well for the kind of things that I'm doing for software development as well as video editing. So a lot of random reads and writes all over the drive. These deliver on that. I've had the 970s in my last build for years. I went with the 980 for this build, and it does work well for everything that I'm doing so far, and all my benchmarks seem to indicate that. So to keep the CPU cool, I went with a liquid cooler. I went with a 360 millimeter radiator, and this is a 3-fan configuration, and it's a water cooler. Now, and I looked into whether I should use water cooling or air cooling on this particular build, and I think I went with water cooling mostly because this one allows the CPU temperatures to stay cooler when you're doing a lot of bursty activity on it, which is typical of things like compiling code or working with databases. Now, you can sustain long-term CPU activity on this water cooler as well, and it will definitely support that. I ran some Cinebench benchmarks on this, and the thermals capped out at around 80 degrees, and it was able to run full tilt with this particular radiator under Cinebench for about 20 minutes, and everything was fine with about 80 degrees and without thermal throttling this particular CPU at all. So again, this thing keeps it nice and cool. And we'll look at how the setup I did for the build, and when I go through my build montage here in a moment. Now for the thermal paste, I went with this Corsair thermal paste. I'm not particularly married to the Corsair brand, but this stuff had good reviews. And when I was doing the build, I had to reapply it because I had to pull the block off, and when I pulled it off, the paste had spread nicely over the CPU, and I had to wipe it all off and reapply it, and I'll talk about that when I do my build montage. But this paste seems to work well, and the thermals kind of suggest that it does help create a nice even distribution of the heat, and it's able, and the GPU the CPU and the CPU cooler are able to absorb all of that and then dissipate it through the radiator. Now for the RAM, I went with capacity. I went with this Corsair Vengeance DDR5 RAM. And so I have four 32 gigabyte sticks in this, and that came out to about $600 for that kit. Actually, it's 2 kits, but I put those in there. And these were a little bit tricky to get configured right, but overall, the capacity was delivered when I inserted all of this, and it does deliver on the performance of DDR5 after I was able to tweak it to get the performance that I wanted for this particular RAM. Now, the next set of components are the more negotiable components, or the ones that I have a little bit more wiggle room on. These are not the kind of components that I need to deliver the kind of goals that I have in mind for this particular PC build. So these I can choose different variations if I want to and still get the goals that I have in mind for this PC. So for the motherboard, I went with this ASRock gaming motherboard. It's got a Z690 in it and supports DDR5. Now the Z690 does support DDR4, but DDR5 is out. And I went with that mostly because to get the capacity and the performance spec that I wanted, I needed a DDR5, but you can still get DDR4 boards, and they will perform if you want for certain types of applications. So for this one, I went with this one, and it's a decent board. I wouldn't say it's an overclocker's board, but it does work for my work, and it does open up the ability to tweak everything about the CPU and the RAM and all the timings and all that kind of stuff to really max out your components. And I'm glad I got that kind of feature with this motherboard, because it allowed me to configure this Corsair Vengeance RAM right here, where the default did not register the RAM at the max capacity that it would work at. It actually underclocked the RAM when I inserted all the DIMMs, and I had to go in and tweak the timing and all of that stuff to get it to perform at the published specs when out of the box that it came with. So again, I'm glad I got it, but it's not an overclocker's board. So if you're looking for something that's going to be used for that, I wouldn't get this board. But for my purposes, I'm not overclocking it. I want stability basically within the context of where it says it's going to run at from the manufacturer, rather than trying to tweak it to make it run at a faster rate than what the manufacturer says it should. So this one is going to deliver on that. Now for the GPU, I went with an RTX 3060 Ti. Now I've had a 2060 Ti for the last 3 years, and it's been a great GPU. And to keep it in that same vein, I went with the 3060 Ti, and it does deliver exactly what I want. It's a decent GPU. Now, of course, you can get better. You can get a 3070, 3080, 3090, and I went with the Ti trim. That's the incremental upgrade over the 3060 over the 3060 standard. The Ti is a slightly better performing trim of that particular GPU. And this one had GDDR6, and it had a 3-fan configuration rather than a 2-fan configuration. So maybe gets a little bit better cooling. But again, a decent GPU, not top of the line, not bottom of the barrel. You can get a 3050 or a GTX 1650 or something in that range if you want, more entry level GPU. But this one costs about $480 now. I could have gone more expensive or less expensive on that, of course. Now for the PSU, I went with this Thermaltake Tough Power 850 watt because I'm not running the 3090 or anything that's real power hungry, and I'm not overclocking. So none of the components are going to draw more than 850 watts. I think the total on the configuration for this, once you add it all up, was about I don't know, 700 watts if you're running it at full tilt. At idle, it's much lower than that. So this particular PSU delivers more than enough power to power this particular build that I have here. It's modular and uses flat cables, which is good. Now for the case, I went with this Roswell Spectra D 100 ATX mid tower. It's not a great case. It's not a terrible case. It's something that's nice. It's got a nice tempered glass side panel, and it has the fans with LEDs on them, RGB and all that kind of stuff. It's not particularly premium, but it's adequate for what I did, and it certainly works. And you'll see this case when I do my build montage here in a moment. But this particular case is a nice case for for the money. I think it's Newegg's in-house brand, but for $60, it's a really good case. Now you can get much cheaper cases that are just garbage, and you get much nicer cases that are going to have a lot more premium features. But for what I'm doing, this case is more than adequate for what I'm doing. So again, a great deal on that. So if I was building this for gaming in this particular budget, I might change some things up. Now this, again, I built this for work, mostly for doing software development and video editing. If I was going to build this for gaming, I might look something like this. I would probably use a different CPU. I'd probably go with an i7 12700 KF variant there, mostly because you don't necessarily need 24 threads for gaming, and the i7 is certainly a good CPU that's going to deliver a nice throughput for gaming purposes. And so I might go with that if I was building a gaming PC over a work machine for software development. For a drive, I might go with a Sabrient Rocket Q 1 terabyte because for gaming, you don't necessarily need the fastest drives in the world, because most of the time with gaming, you take everything, you load it into RAM anyway, and the game runs out of memory, not off the disk. And the only time it really goes to the disk if you're changing levels, or it's swapping out for new content that you're loading in as you progress through the game. So you don't need a top of the line drive for that. And so something that's a little bit more modest will still deliver the same kind of gaming experience. So gaming is really not contingent upon that. So again, not something that I would choose there. Now for gaming, I don't think you would need a 4 32 gig DIMMs for that. You could probably get away with 32 gigs of RAM for a gaming PC. And so this would significantly reduce the cost of this. So you could probably go with two 16 gig sticks to get dual channel configuration out of that, and you'd be fine for 99.9% of the games that are out there that they're not going to require 32 gigs. Most of them don't even require 16 gigs of RAM to run. So that's more than enough RAM to run games, and even future-proof it a little bit and come out at a price that's much lower than what I did. But for my purposes, I needed capacity for 64 gigs and beyond, so that's why I went with the amount I did. Now you could do a different motherboard. This one would probably work for gaming. If you wanted to overclock, of course, get something different. I'm not going to harp on that. Now, if I was gaming, of course, I'm going to get a better GPU, because GPU performance is really going to impact your overall gaming experience probably more than anything else in the build. So an RTX 3080 or maybe even a 3090, which is about $100 more, would deliver much better performance than this one right here. So if you take out these components right here, you would save some money by going with these components. You could turn around and use that money on your GPU and get a machine that's going to be a monster for gaming and probably future-proof for a while for the next few years for delivering the best gaming performance that you can. So again, I didn't build this for gaming. I built it for development. So those are probably the main differences. Everything else probably keep the same, but otherwise those are probably the things I would change for gaming over building something for development purposes. Let's do my build montage here. So this is my family portrait of all my components. There's the GPU, the CPU, the RAM, Here's the cooler, there's the drive, and there's the motherboard and the case. I don't think the PSU had come in when I took this, so it's not in this picture, or maybe it's behind it, I can't remember. But in any case, I took the shrink wrap off of the motherboard right here to get myself familiar with the motherboard by reading the manual. And once I was familiar with it, I went ahead and started the build process. So again, that's the family portrait while everything's still in the box. This motherboard is a pretty nice motherboard. Again, like I said, it's not top of the line. It's not the worst motherboard. It's not the best motherboard, but it does have a lot of nice features that are pretty modern in terms of motherboard tech. So it's as far as the latest features available. So it's got a Gen 5 PCIe slot. I like this motherboard because it had 3 NVMe headers on it. So there's one, there's two. Well, it's got 3 NVMe headers for storage and then one for Wi-Fi that's separate. So you can put up to 3 NVMe drives on this thing without a problem. I only have 2 on it right now, so I have the ability to expand in the future, which I probably will do with another 2 terabyte storage drive. That will give me a total of 6 terabytes on this. I have of course, the 980 Pro right here, mostly for performance reasons, and that's my primary boot drive. I moved one of my other drives out of my last build. It's my data drive, and I put it into this one right here. And it's the old 970, but it still does that. It's a data drive. It's not my primary drive, so I don't use it for anything that's for software development or VMs, but it's for more long-term storage and that kind of thing. So I move stuff over there as I get done working on it. Now, I probably will expand that in the future, like I said, and maybe I'll put a Wi-Fi adapter in this. I don't really need one because this thing is right next to my switch, and I just put Ethernet into it, and it works fine. So a really nice motherboard from that point of view. It's got the USB 3.2 for RAM slots at DDR5. And of course, the LGA 1700 there, 24 pin ATX, which is pretty standard. There's the CPU power header. It's the 8+4 setup there. This thing's got more RGB headers and more fan headers than you could possibly want. It's pre-configured for either water pump or fan, so you can put AIOs on this or you can put fans. It will go either way with this. It's got more, like I said, RGB headers than I care about, and so you can have as many fans on this thing as you care. So 10 fans, maybe more. I have, I think, 6 fans on my my case, if you don't count the PSU fan and the GPU fans. So more than you need for this. And there's all your standard I/O right there for that. And then, of course, you can put SATA drives on all this stuff as well. Then, of course, it's got PCI Express, 1X slots, and there's another 16X slot there. So a very nice motherboard for, in terms of feature sets are concerned, but it's not the top of the line. It's not the worst. But again, for my purposes, it's great, and even has some growth room for adding more storage to it in the future. So here's the CPU after I mounted it. You can see that it's the i9-12900KF variant there. It went right in, no problems there. The main problem I had with this particular mount was when I put on the water block for the cooler, which you'll see that in a minute. But this is after I put it into the case. This case, like I said, is a pretty nice case for the value, and it was very well cut. Everything lined up without any problems. All of the mount points lined up without a hitch. There's one right there, and I think I put a couple. There's one right there. Of course, one in the corner. There's one probably back here, and there's one probably somewhere around there. I can't remember exactly where all the mount points are. Another one right there. And everything worked well for this particular motherboard. Everything lined up well. No issues there. And once I inserted everything, the I/O shield went in without a hitch there. And once I slotted in the GPU right here, it lined up perfectly with the back plane there to get me the ports exposed without having to fight this case at any turn. Now, the precision of this case is great. My main complaint about it is the cable management, which we'll see in a moment why I think this is a little bit quirky for this particular case. And I'm glad I got the flat cables, and you'll see why once we kind of look at a picture of the back of this. But this is the motherboard mounted before I put the AIO on it. Now, the mounting point hardware for the AIO was a big problem. Now, of all the things that came with this, I had some issues with this. Now, what you're looking at here is the back of the motherboard. So this is how it's supposed to be mounted. According to the instructions, you're supposed to have these bolt heads on the back of the motherboard, and there's a little slot underneath this particular cutout right here. It looks something like this. It's got this flat side that the one side of the bolt is, and it comes around and it's got these divot in it, and it comes around like this. So you can either put the bolt right here or you can put the bolt right here, and that's how you're supposed to line it up with whatever socket that you're using. For LGA, I'm not sure that it was one or the other, and this particular AIO is supposed to support a LGA 1700. So I don't know if this was an error on MSI's part or ASRock didn't drill these holes correctly. I don't know who's to blame here. So this, when I put these bolts in to mount the block onto the CPU from the front, they were crooked and I couldn't get the screws to tighten down in any case. So to solve that problem, I basically just flipped the bolts over, and the top bracket for this particular CPU didn't have these little divots in here, and so these could slide around a little bit more, and I put the thumb screws on the bottom because the threads could move freely through that slot right here, and so I could move those threads around a little bit more freely, and so I put the thumb screws on the bottom of the motherboard and tightened it down from that side rather than on the top where they're supposed to be. And it works. It's not supposed to be this way. It made mounting it a little bit harder, but overall it did work to accomplish mounting this particular AIO onto this CPU. And after I ran all the tests on it, all the benchmarks, everything, it's keeping it cool, so I can't complain about it, but it's just not how it was supposed to be done. These are supposed to be on top, not the bottom, but other than that, I didn't really have any other trouble with this particular mounting hardware other than this little squirrely thing right here. So this is the reason I actually had to take the water block off of the CPU, because when I ran into this problem, I had already kind of tried to mount the screws. I got, I think, one on and then maybe half a turn on one of the other ones before I realized that something wasn't right. But by that time, it had spread the thermal paste all over the CPU. And so when I backed all that out, I could see that the thermal paste had spread nice and evenly, and it does work to cover the entire CPU, which is what you want, so you don't end up with any hot spots on the CPU. And so I know I'm getting good contact with the water block and the CPU as well once I got this thing mounted in a way that was going to keep it cool without having to struggle against the mounting hardware. But once I got everything mounted and everything was on there, it works fine, and I don't have any complaints about it. So there's the mounted water block right there. You can see that those bolt heads right there are on the top instead of on the bottom like they're supposed to be. But other than that, that's the only really issue I had with this. And of course, there's the pipes going back to the rad, which is on the front of the case. So my rad mounting ended up looking like this. So this was the stock fans for this particular thing. So I did a front mount on this for the radiator, and I went with a 360 millimeter radiator, and I selected a case that would support it. And so to make this so it didn't have any kind of tension between the fans, I removed the front panel fans that came with the case, which are these fans right here. These were the ones these are Rosewell fans, they're case fans, and I replaced it with the 120 millimeter rad fans. So these are the ones that came from MSI that are supposed to go with the radiator right here. And so this is the front panel. It's right on top of this mesh right here, and this mounts to that, and this mounts to the other side of that. So this draws in cool air from the outside and blows it across the radiator, across it like this, and it doesn't, and you don't get any kind of like negative or positive pressure scenarios where you have case fans that are kind of competing against these. Rather, it's just blowing it across cleanly without any kind of blockage on the other side from any kind of fans right here that you might be mounting on this side. And if you were to keep the case fans in there and you put these other fans on the internal, you would still end up with that same kind of interference across the radiator. So to keep that air more free flowing, I took the case fans off, put these on the front in a pull configuration to draw in cool air from the outside, and then I took the case fans and I mounted them onto the case for exhaust fans. So it creates, I guess, maybe a negative pressure on internally to the case rather than having something across the radiator with that. And so, with all my tests that I ran for cooling, this works. It works well. It keeps the CPU again around 80 degrees Celsius whenever I am running Cinebench at full tilt for about 20 minutes. It doesn't thermal throttle the CPU at all, so it's able to keep this particular CPU nice and cool with that configuration. So again, it works well. Of course, this is the GPU. It's a 3-fan configuration. This keeps it a little cooler. Nothing particular novel about that. Of course, there it is after I've mounted it. And it's got a rather large heatsink on it, and there's 3 fans that are blowing across it. And of course, it's a PCI 8 pin there to keep it powered up, in addition to the power that comes off the bus. So again, just a standard 3-fan card, nothing fancy there. It's not real heavy, so you don't really get a lot of like GPU sagging with this particular motherboard, and it's a solid mount onto the case as well. So again, nothing particularly hard about mounting this or anything like that. So here's my biggest complaint about this case is the cable management. I was hoping that there might be some better cable management for this particular case. Now, this particular case doesn't have a lot of cable management right behind the motherboard to handle anything like these cables that come up here to power the CPU, for instance. I was hoping that there would be a little bit more in terms of trays or some kind of routes that you could pass that through, but otherwise you end up with something that looks like this. And I was glad that I went with the flat cables because those allow me to kind of lay them a little bit flatter so I can get the back panel on this. And my thinking is if they could have made this thing about a 1/2 inch wider, it would have been better for cable management for this particular case. But that's my biggest complaint about this. Basically, the only thing that you have is these holes right here to run the cables through, but you don't get a lot of cable management other than this kind of space right here. And I pulled all the IO headers right here and put the cables from that over into this space right here, and I try to zip tie them and keep them as neat as possible. This is the controller for the case fans right here, and that come with the case, and it draws some additional power. It uses just a Molex connector for that, and it creates this kind of rat's nest because everything kind of comes together into this this particular central location right here, and it kind of creates a rat's nest. It made cable management a little bit more difficult than something that might be done more efficiently if it was done at a more premium type build. So I kind of had to put all that in there and kind of cable tie it all together, zip tie it all together, and do the best I could to kind of keep it flat. And then of course you had the power connectors for the ATX 24 pin, as well as things like the USB types of headers and all of those other things that come up through this as well. Now, this did have a drive mounting system right here for a spinning disc, as well as other SATA type drives. That I took that out so that the cables would be a little bit easier to access right here. And so I took that caddy out. I'm not going to be using it because I don't have any spinning disc, or I don't have any SATA drives, so I don't need it. And that allows me to have a little bit more room for the cables down here. And there, of course, this is the PSU once it's been inserted and mounted into this guy. It has a big fan on it, I think 144 millimeter fan on it, and that draws cool air from the bottom of the case and then exhausts it out the back. And overall, this is the cable management. It's not the best in the world. I mean, it could be cleaner, but otherwise, that's my biggest complaint about this case. But otherwise, it's a nice case. This is the other side. This is once everything's been inserted and everything's ready to boot. From the top, it does look nice, and you put the glass panel over it, and everything works really well in this case. I was rather pleased with the outcome. So I took some of the case fans off the front over here on the other side of the rad right here, and I mounted them on the top here. So I made exhaust fans right here, and then there's the one that came with it. Now, I'm missing some IO shield right here for these slots, because when I was putting this thing together, I had some trouble getting this motherboard to recognize the GPU. After inserting it, pulling it, pulling it, I was like, I don't know what's going on with this. So I ended up pulling a 2060 that I had for another desktop that I use, inserting the 2060 into that, getting that GPU working first. And then I reinserted the 3060 into this and got that one working. It was a little bit of finagling with this particular motherboard to get it to recognize this particular GPU. But once I got it working, it works great. Everything, and I saved the BIOS settings. Everything works fine, and now everything is up and running with this particular GPU and RAM. And of course, there's the RAD, there's the RAM, there's the RAD, there's the RAM, there's CPU, GPU, and of course the storage right here. I don't think I've put this 970 in it at this point, but you know it's actually kind of underneath this right here, and it's ready to rock and roll. And that's my build after I got all the cables and everything else plugged in. There it is, powered up. There's me with my USB drive installing Windows on this thing. I think it took about 5 minutes to install Windows. That the USB 2.3.2 is really fast on this particular thumb drive, and then the actual NVMe storage on this thing is rocket fast as well. So it took no time to boot this thing up and install Windows on it. And once everything was up and running, I mean, again, it was bang, 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 and that was the easiest part of the whole build. And here's the output from the BIOS. You can see here's the motherboard model with the 4.02, which is the latest BIOS version for this. And there's the CPU report out. This is the processor speed when I took this. So the clock speed at 3200 megahertz, and of course that's going to go up and down depending on whatever workload you're putting on this. 128 gigs of RAM, and this is after I tweaked it to get the best performance out of it. It's spec'd at 5200. It came in at default around 3200 or 3600. I can't remember exactly which one it was, but after tweaking it in the BIOS, I got the 5200 out of this RAM at full capacity. And so, again, there it is, configured, everything's running. Of course, I ran benchmarks on it for this particular build, and it came out well. Then after I tweaked this RAM to get the published spec that it's supposed to have rather than taking the defaults. And there it is, hooked up, booted with Windows installed on it. After I installed some software and ran some tests on it, it looks kind of like a speaker with these radiator fans on the front of it rather than just the circles that came with the case fans. But again, that's the final product with my red LEDs. I put all the case fans to red, and then I set my keyboard and mouse to match, so it just glows red and there's no pulsing, there's no flashing. I really don't like RGB, but turning it to red was just made it look nice. I'm not a big fan of, as my friend put it, unicorn puke, which is all the rainbow colors just going off constantly. That's makes my eyes hurt. But red seems to work really well with this particular build, and it just looks nice on my desk, even though this picture doesn't really do a lot of justice for it. So that's my montage. Let's go and look at the performance benchmarks over on UserBench. You can look at these, take them for what they're worth, but just to kind of give you an idea what that looks like. So here's a benchmark from User Benchmark. I don't put a lot of stock in benchmarks because they're really nothing more than just a way to compare your system to other systems that tell you if your system is performing as it should, within the context of what you can expect from the hardware you pick. So against other systems of similar builds, my machine seems to be doing pretty well. It's not the best, it's certainly not the worst. So this is what we're looking at here. Says it's throttling, but I don't think that's accurate because I have that setting turned to maximum performance. When I turn this on and I tweak it, it doesn't really seem to change even if I ran this benchmark again. But overall, this one says it's running in the 79th percentile, whatever that is, with the actual performance and expectations within this particular kind of processor and CPU, GPU, etc. So this is the CPU I selected. It's again doing well there. There's the GPU is doing well there. There's the storage. This one I kind of expected for this particular storage. It's great storage, and it's going to perform really well for what I'm doing. And then of course there's the memory. After tweaking it, it does come out pretty well for this particular memory that I put into this machine. So a great performing machine. I'm not overclocking this at all. This is just as the chips were intended to perform, and based on all this, it looks like it's performing within the expected thresholds where it's going to be running for the workloads that I'm going to be putting on it. So again, another successful build. I think it's a great build, and it's going to perform well for the next few years when I'm going to be using this for work purposes. If you like this content, please consider checking us out online at www.winelect.com, where you can find several blog entries about topics related to Microsoft Azure and software development. And you can also subscribe to this channel by clicking the subscribe button below and then clicking on the bell icon to receive notifications when new content becomes available. Until next time, thanks.